Hi guys, good day. This is Ariel Samarita and I'm from II-ACSAD, and today I'm going to discuss about the derivative of a function. Okay, so if the function is a constant function, we can just write the derivative of a function as f prime of x is equal to 0. So any constant function is just equal to 0 as its derivative. Example of a constant function is f of x is equal to 3. So we can just write this as f prime of x is equal to 0. Okay, so the second one is the power rule. So any function that has an exponent, we can just write it as f of x is equal to x raised to n. So the derivative of that function is just f prime of x is equal to n, which is the exponent, x raised to n minus 1. So we will just deduct 1 to the exponent of that function. The example of that is, let's say we have f of x is equal to x raised to 5. So the derivative of this function is f prime of x is equal to 5, which is the exponent of that function, x raised to 5 minus 1. So we can just simplify it by 5x raised to 4. So this is the derivative of the function f of x is equal to x raised to 5. Okay, so the third one is the sum rule. So let's say you have two functions that you want to add or subtract to each other, and you want to get the derivative of those two functions. So we can write that formula as f of x plus or minus g of x. So we can get the derivative of that as f prime of x plus or minus g prime of x. The example of sum rule is, for example, we have here a constant function which is 4 plus power rule as x raised to 10. So we just need to get the derivative of these two functions. So if we have 4 using the constant rule, we have 0 here plus x raised to 10. The exponent of this function is 10, so we will now move that exponent to as a constant, copy x, and then 10 minus 1 as what is written here on the formula on the second rule. So we can just simplify this function as we can just cancel 0, so 10x raised to 9. So this is the derivative of this function. Okay, so moving forward, we have the product rule as our fourth rule. So the product rule formula is just as f of x times g of x. So we can get the derivative of that as f prime of x g times g of x plus f of x times the derivative of g of x. Okay, so the example of the product rule is, for example, we have a function here, p of x is equal to 10x cubed times 6x. So we can represent 10x cubed as f of x, and the 6x as g of x. So using the previous formula, which is the f prime of x times g of x plus f of x times g prime of x. So f prime of x, we should get the derivative of this function. So the derivative of this function is, using the power rule, you need to get the exponent of that function times the constant x. So the exponent is 3 minus 1. And we just need to copy g of x since this is there's no prime, or we shouldn't get the derivative of that function. So we just need to copy g of x, which is 6x, plus copy the f of x, which is the 10x cubed times get the derivative of g of x, which is the 6x. So using the constant rule, we should have 6 as the derivative of 6x. So all we just need to do is to simplify this equation into simplest form. So 30x squared times 6x plus 10x cubed times 6 is equal to 180x cubed plus 60x cubed. So the final answer should be 240x cubed. Okay, so going on to our topic, which is the derivative of a function, we have now here the quotient rule, which is the fifth rule. And actually, there's no difference from the quotient rule to the product rule, since we just need to change the sign this um, of this equation or formula, and we just need to get or divide the whole equation or function to g of x squared. For example, we have here a function p of x is equal to 2x squared all over 6x. So as what we did earlier, we just need to represent the 2x squared as f of x, and then the denominator 6x we need to represent as g of x. Function, we will get 4x multiply to g of x, which is just 6x, minus f of x, which is 2x squared, times g prime of x, which is just 6 all over the g of x, which is 6x, and don't forget the exponent too, so we should have this here as the exponent. So we just need to simplify the function, so we will have 6, 12, 18, 24, 24x squared minus 8, 12x squared all over 6 times 6 is equal to 36x squared. So when we simplify this, 24 minus 12 is just 12x squared all over 36x squared. So our final answer here is just 1/3, as 12x squared divided by 36x squared is equal to 1. Okay, so the last two functions that we have here are the logarithmic function and the exponential function. So any logarithmic function is just represented as f of x is equal to ln x. So the derivative of that function is just f prime of x is equal to 1 over x. And any exponential function is just the same as its derivative. So there's nothing to worry. Now we have here the logarithmic and the exponential function. Okay, so to sum up with our topic for today, which is the derivative of a function, I actually have here a formula, and let's just exercise what we have learned today. So I have here a function f of x is equal to 5x raised to 4 plus 3x raised to 2 minus 4. So as what we discussed earlier, with the help of ano to? Ano yung pang... Okay, so what we as what at what ulit. As what we discussed.
Okay, 1, 2, 3, go.
Okay, so as what we have discussed earlier, we have here a function f of x is equal to 5x4 plus 3x squared minus 4. So let's get first the derivative of this whole equation using the sum rule. And to get the derivative of each term on this equation, we need to get the product rule. So using the product rule, we just need to copy the exponent 5, multiply by the exponent 4, x raised to 4 minus 1, plus we just need to do the same here in the second term, which is 3 times 2x raised to 2 minus 1, and the derivative of the constant function, the first rule that we discussed earlier, is just 0, because any constant term, the derivative is just 0. So let's just simplify this equation to 20x 3, 5 times 4 is equal to 20, x 4 minus 1 is equal to 3, plus 6x, and this is the derivative of this function.